solid three-dimensional object, usually by laying down many successive thin layers of a material. 3D printing has become popular so quickly because it makes manufacturing accessible to more people than ever before. This is partly due to the price, which the starting price for a basic 3D printer is about $300, but also the small size of the printers compared to traditional manufacturing. So next, what is EBM? EBM is a metal additive manufacturing process. It usually used in all kinds of industries, everything from aerospace and energy to medical devices such as turbine blades, medical implants, satellite brackets, and else. The EBM starting point is a vat of powder metal. That powder metal is fused together layer by layer to build the solid metal part. It's an electron beam doing that fusing. Compared to more common layers powder bed fusion, this is higher energy process. The electron beam is a higher energy source. EBM works by typically takes place inside a machine under vacuum at very high temperatures. So you start by spreading a layer of metal powder across your build area. You preheat all of the powder and then you use the electron beam to fuse it together, melt it together just in the place where you need to build up your part. You repeat that process over and over and eventually end up with something like a semi-solid block or cake of powder that has all of the preheat powder regardless of whether or not it was melted with your solid parts inside. So you need to break your parts up, depowder them, and then continue on with the rest of the workflow. Furthermore, what is the advantages of using EBM? That must be the higher energy source make it possible to use larger diameter metal powder. That heavier powder metal is easier to work with, safe to work with. EBM can effectively cut very thin holes of large aspect ratio that can cut almost any programmable hole shape. Remember that preheating of all of the build layers produces a finished build that is very hot. It needs to cool down. Cooling is part of the process. It takes place inside the machine. Can take a few hours. Powder removal can be a challenge. It is because EBM allows for lots of geometric intricacy, and you are also using a large powder particle size which can add up to parts with powder trapped inside that can be difficult to get out. So you might need additional post-processing steps, things like ultrasonic powder removal, or you may need to add extra inspection into your process, just to be absolutely sure there is no unmelted powder inside. Last, compared to other powder bed fusion, EBM produces a coarser surface. Laser powder bed fusion has an advantage when it comes to very fine precision work, but both of these processes produce parts that are very close to net shape. That's all for me.